So good evening. Welcome to MSD at Home with Professor Philippe Block from ETH in Zurich, Professor Jane Burry, Dean of School of Design in Melbourne University of Technology, and Associate Professor Roland Snooks from RMIT University. My name is Paul Loh. I'm a senior lecturer in digital architecture design here at Melbourne School of Design at the University of Melbourne. And I begin this evening's proceeding by acknowledging the traditional owner of the lands on which these events took place here in Melbourne, the land of the Wurundjeri people of the Kulin Nations, and to the traditional owner of the land wherever you are. So I pay respect to their elders, family, past and present. So earlier this year, part of Melbourne Design Week, I curated an exhibition titled Future Prototyping with Monk Q of United Make and David Leggett of How to Make. Here at the Melbourne School of Design and Dulux Gallery, the exhibitions bring together 36 projects from significant institutes and design practice across Australia together with the global research partners. And the aim is to survey this current state of design, innovations within our context, and examine the relevance of making to our society. So the exhibition is now part of the Melbourne School of Design virtual collections. The website also contains a guided tour by myself, as well as an online version of the catalogs. So this is the catalog that was being published for the exhibitions, with a foreword by Professor Jane Burry. So during the exhibitions, we plan to have a whole day symposium with a keynote roundtable discussions on the future of fabrications between Jane, Roland, Philippe, and myself. So that event was unfortunately interrupted by the lockdown, by the COVID-19 lockdown. And it is with great pleasure and excitement tonight and this evening that we can reconvene these conversations 3 months later. So this conversations is part of Melbourne MSD at Home series, where we invite prominent figures and thinkers within the field to reflect on our current normal caused by the global pandemic that we're all experiencing right now. So events of the past few months has already prompted many of us to reflect on our disciplines, the way we practice architecture, design and constructions, and questions relevance to our society. So tonight I have invited 3 speakers to rethink the role of technology in design and construction post-COVID-19. We reflect on how technology allows us to rethink the future of constructions and design. And I'll soon ask each of the panelists to do a short presentation of about 10 minutes to set the scene. And hopefully through the projects, we'll see waste reduction fabrication strategies, or to look at reusing waste in conjunctions in relationship to constructions. We might even see hybrid construction techniques to resilience in geometry. So after the 3 presentations, we'll dive straight into discussions, discussing some of the issues through their work, through the speakers' work. So I'll now do a quick introduction. So what I'll do is I'll do the introduction to all our 3 speakers in one go, so you don't have to listen to me interrupting while during the presentations. So many of you in the audience will have already know a lot of their work from various platforms and other previous lectures. So hopefully I would like to give more time to the discussions, to our discussion. So for our audience, please feel free to pose your questions via the Q&A functions that's on the bottom of your screens during or after the presentations. And I'll try my best to weave your questions into the conversation later on. So our first speaker is Associate Professor Roland Snooks from RMIT University. Roland is also the Director of Architecture Practice Studio Roland Snooks. His design research explores behavioral processes of formations that draw from the logic of swans, intelligence, and multi-agent algorithms. Roland has taught widely in the US, including Columbia University, UPenn, SCI-Arc, and Pratt Institutes. He received his PhD from RMIT and a Master in Advanced Architecture Design from Columbia University, where he studied on Fulbright scholarships. Roland directs a research lab at RMIT University to explore the architecture design implications of emerging technology with a focus on computational design and additive manufacturing. His work has been widely exhibited and acquired for permanent collections by institutes such as the Centre Pompidou and Frag Centre. After Roland, we'll invite Professor Jane Burry to speak. Professor Jane Burry is an architect and Dean of the School of Design at Swinburne University of Technology. She's founding Dean for a new practice-centered architecture, urban and architectural engineering program, focusing on the future of technology, human and non-human well-being and urban ecologies. Lead author of the New Mathematics of Architecture, editors of Designing the Dynamics, and co-authors of Prototypes for Architects, Jane has over 100 other publications, a PhD inspired by Basilica, by her experience in the technical office of Gaudi Sagrada Familia Basilica with Professor Jane Burry, Professor Mark Burry, was titled Logic and Intuition in Architectural Modeling, Philosophy of Mathematics for Computational Design. Recent collaborative research, teaching, and postgraduate supervision addresses the interface of architecture with acoustic, thermal, and airflow dynamics, and the role of simulations, digital fabrication, rich data gathering, and AI in more sustainable and enlivened design. And our final guest speakers is Professor Philippe Block of the Institute of Technology in Architecture at ETH Zurich, where he leads the Block Research Group with Dr. Tom Van Mellers. Philippe is also director of the Swiss National Center of Competency in Research in Digital Fabrications. Philippe studied architecture and structural engineering at Very University in Belgium and at MIT, where he earned his PhD. With the research block groups, he applied research into practice on the design and engineering of novel cell structure, and Philippe has won numerous awards, including the Rosler Prize, the most promising young professor from ETH Zurich. So without further ado, Roland, if I could ask you to share your screen and take it forward.
Sure. Look, Paul, thank you for the introduction and the invitation to be part of the event this evening. So I'm going to discuss the relationship between algorithmic design processes, robotic fabrication, and the intricate architecture that this can generate. I'll look at this through the work of my practice studio, Roland Snooks, as well as the lab at RMIT. But to begin with, I want to frame this briefly in terms of its relationship to the current pandemic and its fallout. So while I'm fairly skeptical that the pandemic will have a significant lasting impact on architectural design and fabrication, there are perhaps two implications of the coronavirus situation that are relevant to this work. One is that the pandemic has highlighted the need for flexible manufacturing, and we can see this in the way additive manufacturing has been employed to print PPE or ventilator parts. And secondly, the disruption to supply chains. So this is emphasizing the importance of local manufacturing and distributed production rather than a dependence on international logistics. So both of these implications are going to create a renewed focus on advanced manufacturing and in particular 3D printing, and perhaps help to establish the conditions to accelerate the adoption of these tools within architecture and building construction. So I want to just, within that framing, jump into the work, and I'm going to try and take a really fast section or slice through my work and try and describe the relationships. So methodologically, my work is based on a generative design approach that I describe as behavioral formation. And this is something which draws upon the logic of swarm intelligence and operates through multi-agent systems. And so this is an approach in which design intention is encoded into individual entities. I describe them as agents. And through the interaction of these agents, design intention self-organizes and it leads to emergence of architectural form, structure, and tectonics. So in particular, one aspect of this that I'm going to talk about today is an algorithm I describe as an agent body algorithm. And so this is effectively an agent which then connects to other agents through a series of limbs. And in doing so, creates a continuous lines of structure, ornamental effects, and structural networks. In doing so, this is an architectural design approach which creates intricate geometries which are neither really surface or network or volume, but can really be described as something which is like a thick fibrous mass. And the creation of these in physical material is something that's very difficult. So at a small scale, perhaps we can print these directly. So this is an aluminium print where it's only about 600 mil across. Each element is only about 0.5 millimeter in diameter. It's about over 1 million of those small elements. And it creates a series of different effects at different scales. This is a very small project we produced for the Pompidou Centre about 2 years ago. But it's part of an algorithmic inquiry we've been working on for almost 20 years. And these particular geometries, we've been trying to figure out ways of building them for the last 7 or 8 years. And so what I want to do today is sort of show this cross-section for a series of techniques for designing or fabricating these geometries. So firstly, we started looking at these in terms of composites and the way we could compress surface structure and ornament into a single irreducible whole, where they're interdependent. And in this case, the network of agent bodies was became the sandwich material within a thin fiber composite. We did this on several projects at a series of different scales, using a number of robotic fabrication techniques, as well as more traditional boat building techniques like this fiber layer technique. They were quite complex and difficult ways of building something. We've also explored simpler ways, like using flat sheet material, which has been laser cut, and then using it to find its own form. And we've also attempted this in things like fiber composites, where we're looking at the way you can make a fiber composite without a mold. Now, in this progression of projects, we've gone from something that was thick and fibrous down to something which becomes very thin and lightweight. So an alternative trajectory we're looking at is the way we build these agent bodies, or the lines of these agent bodies, through robotic rod bending. And what became interesting to us in these projects was we're working with a very volatile algorithm, which is hard to refine because of the sort of the level of population it works at. So what was necessary is to understand all the constraints of the robotic processes and then build those into the algorithm, so you know that whatever the algorithm generates through this sort of wild and volatile process, it's inherently going to be buildable within this fabrication process. So this second strategy was really looking at building lines. So we had these two alternative problems. One dealt with surface, but no fibrous mass, and the other was all fibrous material and no surface. And it wasn't really until this project that we tried to bring those two things together. And in bringing them together, we realized that we needed to develop a different type of construction process for it. And so this is when we started looking at large-scale FDM 3D printing, and that's what I'll focus on the rest of this short presentation. And it was really a shift in the way we think about the production of this. So it was a shift from building the network of agent bodies and then trying to skin it, to printing a skin which we then cast in a fibrous network into. And so in this case, we're casting fiber reinforced concrete back into a series of prototypes, both within skins and ones which were just simply networks, and testing that through a whole series of projects. But this is not really the type of geometry that large-scale 3D printing has a bias towards producing. Large-scale 3D printing inherently wants to be producing a continuous line, a continuous surface, so without a change in topology. So with that in mind, another set of projects were developed in which we were looking at a continuous surface, in this case a surface where each control point is an agent. And through the interaction of those agents, we get this, this rippling or corrugation. And a lot of the challenge of building this particular project, which is out at Monash University for SensiLab, was about how you 3D print polymers in permanent buildings. Like, how do you overcome building codes and in particular fire codes? So this was the first time we had a chance to apply it to a real building. It's a small meeting room. It's an internal project, which was really about the interest in the reflection and refraction of light. Our interest in this work is really about how you scale it up, though, and how it can tackle larger architectural projects. We had an opportunity here at the NGV. This was a collaboration with sound artist Philippe Block, who took a whole series of recordings from the Antarctic. And what we're trying to do with this work is trying to capture some of that atmosphere of where those recordings were taken from, and try to build this through these techniques. So in many ways, this is a project that's about atmosphere, about the lighting effects that come through this 3D printing, and the way that changes from day to night. And also the way that this object relates to the sort of the richness of the of its host of the room, and the way it frames the Leonard French ceiling. So the project's made from about 70 of these 3D printed panels, which are interwoven with, in this case, a folded steel structural frame. So this in many ways goes against what we're attempting to do. I mean, this separates structure and skin, where the agent body network is the folded steel structure. And I guess since doing this project, our attempt has been to, how do we start to reintegrate the skin and structure back together? And so part of this has been about, can we embed the steel structure into these plastic printed surfaces? And more recently, we're looking at other ways of embedding structure. And so this is an attempt to embed carbon fiber structure into 3D prints. This idea that we could print a series of conduits which get infused with carbon fiber and can also take up the jointing system. So this was originally intended for this project for RMIT University on the Brunswick campus. And it's the skin for several studios. And so in this project, we're looking at what is the, how do we create a space between these walls? What is the layering of space between them? But unfortunately in that project, due to value management, the carbon fiber didn't make it through to the end of that project. But it's something we've been continuing on doing in sort of adjacent research, parallel research, looking at the way we can integrate carbon fiber structure within the printed surface. And it was in this project we were able to achieve this. This is a project for the Shenzhen Architecture Biennale that was completed late last year. And what this is looking at is really the way all these three things come together. Like, how do we bring together structure, surface, form, and I guess the sort of the topology of form together into one irreducible element. So it's printed in a series of parts which were infused with carbon fiber, assembled, hoisted into place. And so I guess in many ways, this is the project that really has tied together a lot of the threads I've been trying to quickly discuss in this presentation today. But I'm sort of out of time, but what I'll do is I'll try and quickly wrap up. And I guess what I've been trying to do is, by taking you on this sort of rapid cross-section through the recent work, I was hoping to demonstrate the interrelationship of design processes and fabrication techniques, and importantly, how they influence each other. So, how this interaction has developed across a sequence of projects in which a tectonic logic and architectural language has evolved through successive projects. Thank you.
Thank you very much, Roland. Jane, can I ask you to share your screen and present? We'll come back to discuss the work.
Okay. Well, thanks very much, Paul, for the opportunity to contribute today. And it's just fantastic that we've been able to pick this conversation up again after the abrupt interruption in March. So as you alluded to in the introduction, thanks to your great introduction, I had a sort of quite an early introduction to digital fabrication, and partly just through 1980, I started studying architecture, and I'd just come back from spending a year in a ashram in South India, but I met somebody who'd just spent their year in the basement of the Sagrada Familia Basilica in Barcelona, and we later went on to be partners. So through the 90s, I got to really at least see secondhand that if you could get your hands on an expensive piece of kit, like a Unix computer for 100,000, and you could use aeronautical software and didn't mind working through a programming interface, that there were just amazing possibilities for architecture, and also that kind of link between in this case, the drawing, the models, working backwards and forwards iteratively, but also to the digital models, looking at optimization and into the physical world, and how this digital technology was really joining all the dots for us. And it seemed to take quite a long, so by the early 2000s, I had got a more hands-on involvement in the project, and that was just very influential on thinking. But it seemed like it took quite a long time for those technologies to really take hold in mainstream practice, even though there was so much sort of creative furore around what could be produced that way. But then looking back in the most recent decade, what I think has been interesting is to then, once the digital computation took off in practice, is to just look back and realize what an explosion of kind of Bauhaus activity it actually engendered in terms of physical making and prototyping in practice. And so we had the privilege of looking at 50 projects across leading practices and seeing where that had taken them. I'm just going to talk quickly about a couple of projects that we were lucky enough to exhibit in the Future Prototyping exhibition at MSD. So once you've sort of got the hang of all that geometry, I suppose there's two big questions that have been really interesting. And what you can do with that and what you can link it to. And obviously with this planetary crisis we're going through now, one of those is just looking at reducing carbon, reducing waste. And this is really what this project, Suspended Remnants, is all about, led by Kim Barber at UQ University. Particularly with timber, you cut down a tree, it's got branches all over the place, you take you cut it down to 6-meter lengths and put them on a truck. You take them back to base and scan them and identify where the defects are throughout. Well, take the longest lengths and defect-free lengths for structural timber, cut down some of the rest, and then throw out 50% of it basically into wood chip and sawdust. So there's a huge potential there for sort of regaining some of that material and looking at what you do with it. So we were looking at a sort of inventory of random lengths of what sort of the remainder after all the knots and defects have been taken out, and wondering if you get a lot of scan data these days. There's really sophisticated scanning technology going on inside the mill, so you get all the data with it in terms of size and where the knots are. And marry this up, back to the Gaudi story, marry this up to the flexible funicular way of modeling and looking at equilibrated structures. Could we start to look at that and through the sort of digital smarts and using computation for what it's good for, which is that horrible kind of repetitive kind of numerical crunching, get to a good fit, a sort of best fit between that random inventory of timber and a funicular or catenary fully equilibrated structure. So there was a lot of fun involved in just thinking about how you would detail something like that. It was originally designed to go to Barcelona last year to the IASS Form and Force competition and exhibition, and therefore had to be designed around suitcase dimensions, and then found its way back into the Future Prototyping exhibition this year. And the second project also at the Future Prototyping exhibition was FabPod 2. Now, so we've talked a bit about waste and the sort of the computational opportunities there. Lots of low-hanging fruit in that space. I guess the other big preoccupation has been just thinking about how do you bring more real-time feedback into designing, and what does that mean in terms of tying what you make and what you design back to its impact on human sensory experience, and sort of understanding the interaction between people and form. So this project is all about sound. It also has a link back to Gaudi. When the interior of the basilica was completed 10 years ago and the Pope came to consecrate it, it was sort of clear of scaffolding for the first time, full of musicians. We found out that although it's a very, very resonant space, it's also a space that has a very even sound distribution around it. It's very diffuse Just as it diffuses light, it also diffuses sound. And that seemed to be something to do with the way that Gaudi's use of surfaces was scattering the sound. So we did some experiments of our own, just to see if hyperbolic surfaces and hyperboloids of revolution in particular were great scatterers. Kind of were able to establish that that was the case across, in some cases, a very wide range of frequencies. And then took that knowledge back when it came time to think about open workspaces and how you can hold a private meeting. And of course, if you've ever been in one of these pods, there's a kind of hideous acoustic inside. So could we apply that? And we did that in what became known as FabPod 1, which I think is still sitting at RMIT. But so that's a series of intersecting spheres with similar hyperboloids, if you like, subtracted out of the surface, using a mixture of reflective acrylic, spun aluminium, and absorbent echo panel felt materials to kind of manipulate the sound inside. So you get this incredible clarity of sound inside, but you're actually stopping 17 decibels without having to have a ceiling or a door, which is exactly what one of those little AirPods does for you in terms of blocking sound. And the beauty of that project was that we had it as a prototype for a sort of enduring prototype for a very long time, to look at the way it was performing and compare it to other similar volumes, and particularly to, this is Pantia Alambeghi, who did a whole PhD on just looking at how to optimize, particularly for speech privacy. So in terms of not just the level of sound, but how you understand sound and how it disturbs you in working environments, looking at global shape parameters and bringing that into what's subsequently become known as FabPod 2, which, although it looks in some ways quite similar to FabPod 1 with its oculi and its crazy geometries, it's actually a concave shape on the inside and the outside, which is actually better for containing sound than the first time around. But it's also looking more into manufacturing paradigms. So here for the framing, using folded metal, so that the precision in the system is actually built in to the way that the cells are fabricated, because we found that in the first instance, a lot of the labor and a lot of the sort of manual stuff was really tied up in the assembly, and tried to get that very high level of precision. And secondly, we at this point abandoned the hyperboloids, which are also sort of have quite a big cost in terms of manufacturing, to use a standard ABS conical shape. So you use one mold, make many ABS cones that can be distorted, and using kind of reverse projection, squashing those cones, sort of cutting them with the robot along a calculated trajectory, and then pressing them onto a plane. So each one again becomes unique. Again, it's an irregular shape that's doing the sound scattering within the space, but you know, kind of it has some sort of affordances and some kind of manufacturability. So it's sort of on its way to a much closer to a manufacturing paradigm. There you see Chen Chanhui up the ladder, who sort of led the fabrication drive and took many privileged students, initially from RMIT and more recently from Swinburne, on that journey. And there it is in the exhibition. So I am out of time, but I did want to do a quick plug. If you're fascinated by this stuff, go to the UCL website and download the Fabricate book for free, and you'll find the 3 predecessors, if you don't have them, are also on that site. And join the Fabricate conference, which is also rescheduled now for the 9th to the 12th of September this year online. Thanks, Paul.
Thank you very much, Jane. Thank you. Thanks for the plug on Fabricate. My paper is in there too.
And Roland
and Philippe. And Philippe. All our papers in that book. So all the audience must download it today. Philippe, can I ask you to share your screen? Thank you.
Yep. Okay. Hi everyone. Thanks indeed for the invitation, and too bad that we couldn't do this in person, but it's quite interesting for me to be so present in Melbourne lately, both physically and virtually. So I'm excited to be here. I want to maybe directly pick up on something that Roland said, that I think that this period of COVID makes us think about workflows, about the role we play in responding to this pandemic. But I also believe that that doesn't mean that we should ignore the reality of bigger picture questions that will still remain. And more specifically, I'm referring to the challenge and the challenges that we have as an industry and responsibilities to address these appalling figures. That, of course, these figures are rounded up. These figures depend on what sources you take, but I like the 40, 40, 40, 40 because it is very easy to remember. As a building and construction industry, we're responsible for 40% of emissions, 40% of extraction, which relates to using of resources, 40% of excess, which has to do with waste production, and then 40% of energy consumption. So again, this is where I want to start off with, and this is something where I also believe that this discussion, the role of computation and digital fabrication, but also prototyping is essential. I want to frame this small introduction by starting with David Billington's definition or introduction or coining of the term art of structural engineering, where he boiled that down, that what is really important is to care about efficiency, economy, and elegance. Efficiency has to do with responsibly and as good as possible using a material and placing it where it wants to be. So these master builders like Robert Maillard use graphic statics, for example, to discover these forms and to not disconnect the design step from the engineering step. Economy has to do with obviously the bottom line, how much things cost, how it is realized, and thinking indeed directly of construction from the beginning in the design process, or in another way, fabrication as well. And then it was interesting that these master builders explicitly talked about elegance, that was an extremely important target to be aiming for. So if we now not talk about structural engineering or art of structural engineering, but maybe the goals for structural design, I think these three goals should absolutely be, are essential. But I would add in nowadays ecology and ethics, and I will talk about this a little bit, what I mean by that. My group and we try to clarify that a lot of these targets can be almost naturally for free be gotten with good geometry, so that we get strength and stability and efficiency through the geometry of a structure. And indeed, if you, Jane talked about funicular or the shapes that Gaudi kind of explored. If you extend these shapes, then you can use very humble materials without the need of any reinforcement, glue, things that actually make structures last less long. So here, for example, a cut stone vault. When you get the geometry right, then you can activate local resources, so locally sourced soil that is just compressed without any firing, and that can be assembled just with local labor. Very weak materials, and weak materials typically have low environmental impact. But you could, and these are more postulating, the first are real projects. This is more a provocation, a pavilion that uses compressed waste, compressed Tetra Pak, to again show that why are we not thinking in these type of materials? So going beyond local, going towards recycled materials, and why not even grown materials? And I'm excited that we just got funding to actually, through a small research project, to really explore. These are, for example, fungi, mycelium components. So why can we, should we not start to explore to what extent they really can be used as structural components? to discover this kind of forms, my group develops tools that we share for free that allow you to discover, explore, and also understand why and how these forms work. And so this openness and this sharing, this responsibility of sharing, I find very important. I am very happy to say that next week in the Digital Futures workshop, we will officially launch RhinoVol 2, which is a more sophisticated version to explore and discover these funicular, beautiful, three-dimensional, robust forms. But economy, we also want to then realize these forms in a way that we can start to challenge the status quo. And that is why where we do research, like for example, this knitted formwork that was produced on a standard knitting machine, typically meant to make sweaters or braces or things like that. And then this entire formwork, much like Jane was saying, could then be transported on site, just in some suitcases. And then, not unimportant, what is the relevant level of introduction of computational and digital fabrication here? Doing all of this prefabrication to then on-site being able to work, this was in Mexico City, to be able to work with the crafts concrete finishers. So literally giving them a more interesting canvas to work with. So this balance between what is the appropriate level of control, of introduction of new methods, but also respecting the opportunities and the strengths of local crafts, I find a very, very important and interesting topic. And of course, in the bigger socioeconomic kind of context, needs to be considered, because it's not just about the money, it's also about longer term benefits and kind of opportunities. So this was a shell that we built in Mexico City that we designed together with DIT architects. What you don't see is that it's a complicated rib stiffened shell, so a very complex geometry that was done with a formwork system that costs literally less than 4,000 Australian dollars. So here trying to really challenge ourselves, because unfortunately this beautiful, efficient, curved structural geometry is not standard geometry, and hence typically is associated with a lot of cost and or waste to realize. And so this is something that we try to kind of push. This is, of course, entirely subjective, but I would argue that if you get things right, if there is kind of a connection between the forms that you generate, the materiality, the fabrication, the specific kind of approaches, that there is a natural elegance that emerges from these kind of approaches. Then towards efficiency and also towards ecology, I think we need a much more nuanced and better kind of discussion on what sustainability is. Here, the Guardian labels concrete as the most destructive material on earth, which is factually true. But maybe the reason is that we are using concrete not how it wants to be used. And so by just labeling it as ban all concrete, then we're basically not doing our society justice, because we need a multitude of solutions that are relevant in different contexts. And here, for example, what I'm showing on this slide is that if concrete is actually by itself quite a good material, it's just how we use it in bulk is absolutely irresponsible and bad. And just by reintroducing old techniques, learning from the past, the stiffened arch rather than a beam, concrete doesn't want to go in tension, so it doesn't want to act like a beam, but it wants to act as an arch that is being kept together with a tension tie. Then we save for free more than 70% of material. And indeed, we are now demonstrating this, and you see through one of the early prototypes broken what efficiencies, how much material you can really take out. Then towards ethics, there's two aspects in ethics. I think we have a responsibility to indeed tackle these problems, and we all need to work together. And that is why we develop computational frameworks, for example, Compass, that allows really to share knowledge amongst researchers, and increasingly also to start to have a very effective way to work together with industry. And that is another aspect about ethics, is that we cannot pass on responsibilities to others. We cannot expect engineers to not challenge architects. We cannot expect the efficiencies on site just to come from the fabricators or the contractors without involving them in the design in the beginning. So we need to rethink how we work, and that's also where computation is really essential, and we need to rethink indeed the sequences of how a project comes to be. So to remind you where I come from and the key things that I believe that we still should challenge, and where this topic is so important, the topic of a more integrated design process without the borders between disciplines and passing on of responsibilities and fee control and so on and so on. But I think that indeed we can achieve that by redefining what efficiency is. So how to use a material best is not just about being lighter. Of course, the bottom line needs to always be considered. So our explorations are not for free. We need economy full and frontal in there. And then elegance is, you see it in the middle, key, but ecology and ethics. We need to act, we need to be responsible. It's unacceptable not to be so. Anyway, those are my 10 minutes of introduction, and I'm excited to now go into the discussion, I guess.
Thank you very much, Philippe. Thank you very much, Jane and Roland. That's a fantastic presentation to set the scene for our conversations. I have a number of questions already flowing in from the audience. Just a reminder for the audience that you can put your questions through the Q&A functions on the bottom of the screen, and I will try to weave them in. But before we do that, I have my own set of questions. It's the privilege of being a host, I guess. It's fascinating discussions, and I'm very sorry that I put you guys through this, that I asked you to compress your body of work to literally 10 minutes, because I think there's also some very poignant discussions that we can start to target and then maybe unfold a little bit more. So I want to just kind of start off by exploring the issue of local manufacturing and distributed manufacturing that Roland kind of bring up in his presentations. And I think we all know the 3 months in hibernations. All we watch is CNN, BBC, and we kind of know all the kind of news about kind of how the supply chains are being broken around the world because of lockdown, and distributed manufacturing or local fab labs are to step up to supplement this sort of broken supply chain, and in the sense of micro manufacturing stepping out. In Australia, we do have a very particular phenomenon where over the last 20 years, because manufacturing industries are essentially in a decline, while our construction industries are basically going up exponentially, which only means one thing. That means that all our materials are essentially imported. I think increasingly it's not just the materials anymore, it's including building parks, all the way up to components. And I think last year in my field research, I also learned that some of the steel mold for casting concrete for one of our infrastructure projects in Melbourne is also imported, which is a bit ridiculous really, because you are importing steel, which also comes from Australia. So I think that's kind of this issue, and I wanted to also kind of tying a little bit later on with Jane's discussions on waste and Philippe's discussion on waste on the 5E, as Philippe called it, so in one of his lecture. And perhaps maybe just expand, if you can maybe talk a little bit about your talks on the issue around global supply chain and manufacturing. We talk a little bit already about this idea of funicular geometry, using funicular geometry as a more effective way of designing, I guess. And I think I really like what Roland says earlier as his conclusion, that his practice is very much about this interrelationship between design processes and fabrications. So maybe I'd like to, maybe we can invite you to kind of have a talk about your thoughts on these issues. And yes, of course, we shouldn't be forgetting about the larger pictures. This could be a passing phase, we don't know. Roland, perhaps you want to start, if I could invite you to.
Yeah, sure. Yeah, look, I think some of these things are passing issues, but some of them actually speak to more fundamental, problems. And that's what I think Philip was talking about. Issues around distributed manufacturing and supply chains. Yes, supply chains have been disrupted by the COVID crisis, but one thing that has demonstrated is actually how dependent we are on massive ecological cost of logistics, and if we're able to reduce the logistics costs, then that's going to actually make greater resilience in terms of like crises like COVID, but also perhaps more importantly will actually address the ecological crisis, climate crisis. And so I can see a great deal of interest in Australia currently about distributed manufacturing, and this idea that if you can get the cost of the plant machinery down to the smallest size possible, you can then distribute, micro factories to where the material supply is. And one thing I'm particularly interested in this regard is around recycled plastics. There's so much post-consumer recycled plastics anywhere in the world. Australia is no different. And all of these are actually, of course, where population centres are, which then also means it's kind of regional. I think if you're able to set up a system in which you can reduce the cost of a fabrication cell to make it sufficiently small, then you can align these things to where those recycling distribution centres are, and actually remove logistics costs and actually take advantage of what is very sort of cheap price of recycled materials at the source. They become more expensive when you start to move them around, and also then you reduce potentially logistics costs of things you manufacture.
Philip?
Yeah, I would maybe like to add to that in general, kind of trying to identify what makes sense locally is a good strategy. And what's interesting about this discussion is that when you look at when the target is then additionally to try to find local opportunities that don't overuse virgin resources or new resources, then of course the idea of mining waste, mining looking at additional waste flows and so on becomes increasingly important. And so it's quite interesting indeed to do that exercise. And one thing that I couldn't really kind of elaborate too much on is that that also really suggests that solutions have to be made specific for local context. And it's not just about resources, about waste, about recyclability, but it's also what I try to say about opportunities for new skills and economies and things like that. And so it's really, it's a quite complex socio-economic kind of interwoven problem. But I think it's exciting now that this COVID situation makes us very explicitly think about this more precisely. And then what is the link to the topic today, Loh, is Paul, is that in order to actually activate then these traditionally considered subpar materials or non-structural or non-kind of proper materials, that's where digital fabrication can actually shape them such that they actually start to perform as you need them to perform, or you strategically can upgrade them, like Roland also was showing, where plastics with smart inlays and so on become suddenly real components and so on. And so yes, anyway, I don't know if I hope that was clear, but I think it's interesting to consider waste now explicitly as a local resource, but not everywhere it's the same. Waste is not, and that's what we try to show in the New York City Pavilion, is that actually the invitation came after our African projects, where the client loved what we were doing with local materials and so on, and they said, can you build an earthen vault in New York City for this festival? And we said that makes absolutely no sense, because what is readily available in Africa was indeed the local soil, but that is not available in New York. There you have a lot of waste, so why not making construction out of waste? And again, so it's this dialogue which is interesting.
Jane, I guess that directly relates to your work in terms of kind of using computational information students in terms of dealing with waste.
Yeah, yes, that's true. And I'm, you know, I love the idea of really distributed manufacturing, but I guess that the flip side of that is that you don't just want to distribute it to back to low labor cost places. So I think for me, the flip side of that is that we have got, in Australia, for instance, we have a really robust kind of manufacturing, I wouldn't say past, it's present as well, but we do. And there's another kind of waste to think about in terms of that, which is it's human resource waste in terms of expertise, and it's and great investment in manufacturing plant and as well as expertise. So we lost an entire auto industry. We've lost a lot of our kind of major manufacturing industries. So I think there's a lot of, actually the COVID, I think, has reopened this discussion around repurposing, particularly the kind of even the small to medium enterprises, what they call the mom and pop kind of manufacturing businesses, going back, seeing what they've got, seeing what they can do, and what can you do with that for from architecture, engineering, construction industry. It might be high end because we're like Switzerland, we're kind of a very high cost labor market. But, you know, so I see it as a really kind of an ecosystem. At the one hand, it would be great if we could make better use of the waste plastic, if we could double the amount of the wood that we use once we chop it down. But, you know, it's kind of an ecosystem with many layers to it. And it seems as though there are some hopeful kind of green shoots coming out of the COVID crisis in that regard, a sort of interest in the local again, which I think could be really productive.
Jane and Philip, you both talk about funicular geometries, and Roland, of course, you talk about manufacturing smaller parts. I mean, we have questions on one of our audience asking, how could computational design for structure can be used for developing communities, applied to developing communities? I presume he meant developing countries as such. And I think some of Philippe's work has direct relationships to that. Philippe, do you want to elaborate a little bit?
Yeah, this is a difficult one, because it's also one that I mean, doing meaningful things in developing contexts is extremely challenging, and takes one can do more harm than good when one doesn't approach this with the right local partners and with people that actually understand all the dynamics and the local real requirements. And so what I've recently learned that seems to work, or where there is really demand, because we're lucky to now work with some developers in India and with the government of South Africa on such development projects. And there we are not trying to kind of impose or copy our entire approach to such context, but actually to try to use computational design and digital fabrication on our end to develop initial versions of new concepts and construction logics that can be sent with sufficient kind of safety. I mean, that you feel confident to actually develop something robustly. So actually how we, that is a personal approach, right? But that is how we have now seen an opportunity, indeed in a very privileged different context, that we can, that we take our infrastructure to actually develop locally, to then be able to propose something that might be a good starting point in our opinion. But then the key thing is again not just to insert it and plant it, but actually then to take it as a starting point that then can be made locally relevant, right? So it's not the direct, so it's not the same as what we were talking about earlier. It's not the direct kind of sending information and local distributed manufacturing, but it's actually using prototyping and computational design in advance to then propose a solution. The same a little bit what we did with Knit Candela. That was a full holistic, for us, that was a case study. But if we were to go forward with proposing that as a solution for fast erection shelters for refugees and whatnot, which actually would be a very appropriate approach. Then we would not require the full computational pipeline, but we would send instructions of certain principles that we know that work, that if they are being combined by local communities to be made relevant locally, that they would work. So a similar kind of strategy of doing the work up front and then distill it into principles that in local shops, in local kind of context make sense.
Thank you very much. That kind of nicely lead me to the next questions. Because I really want to touch on how we share information in the future. And I think what is very apparent in the first part of our conversation today is that these COVID situations may not last, we don't know, but it certainly bring out a lot of kind of heighten a lot of the issues. And I think Philippe, you already talked about Compass, which is one of the platforms on the open source platforms and Rhinovolt, and in terms of within the field of computational design and fabrications with advanced knowledge, data is obviously kind of an essential part of the workflow, both kind of within the team and also outside of it. Also, obviously, increasingly practice in the industry eventually. And certainly in the last 10 years, researchers and academics has always been obsessed with examining, inventing new workflow with robotics, etc. So what do you think in terms of how do you think this sort of practice will be accelerated post COVID-19, or do you think we will just be in status quo? I'm partly interested to hear what Roland thinks, because you mentioned your Venice Biennale projects, which is just post-COVID, and obviously it's kind of a strange time, I imagine, because when more or less it's finished, or it could be during that time actually when this kind of pandemic started in China, when the Biennale is happening. So, and also this notion of having to kind of send work out of manufactured locally, but then have to kind of export it or send out to particular exhibitions. I think Philippe also had very similar kind of experience with the Modella project, going to Venice. I remember in your lectures, you talk about the cost of shipping to Venice, etc. Roland, do you want to maybe elaborate a little bit on this? What your thought about in terms of kind of information flow? Where do you think we should go next, and how and where the kind of the gaps are at the moment?
Yeah, I guess it's not quite directed at your question, but one of the things that's been very interesting for me during the COVID crisis is that Australia suffers from its isolation in many ways, and the first half of my career was really spent working in New York and developing a network around there. And the second half of my career so far has been in Melbourne, and I guess one thing that's happened is that suddenly, because everybody's working remotely, doesn't matter where you're working remotely. And so we have, I have PhDs, candidates who are stuck in various different parts of the world, but it's no different from having them stuck there as, the candidates I have who are stuck in their houses down the road. So suddenly there's a kind of a whole lot of a greater access, particularly for Australians, particularly for people who are in more remote parts of the world, to have a kind of much more involved and daily dialogue with our colleagues. And I've sort of found myself on many reviews, reviews at ETH or Bartlett or in the US. And so I think that that's a form of information exchange, and it's a form of exchange partly just through discourse and dialogue, but also through the embodied knowledge within projects, and the way those things are sort of passed around and discussed and debated. So I think that this is something that I would really hope continues. I really hope that this is a kind of really positive thing that comes out of this whole COVID experience.
Not a bad idea. I think time is the only kind of constraining factor there. Sleep, I guess, sleep pattern. Jane, your thought on this? Because you've been dealing with informations almost all your career, no? So.
Information sharing. Yeah, no, I agree with Roland that it's been a very leveling, very flattening kind of experience across the globe. But I'm also kind of quizzical because I wonder it's because we have those networks already, So So yes, your people are coming to review work in Australia. We're going to review work on the other side of the world, and we're talking to colleagues all over the place. But you know, it wouldn't. Could you establish those networks in an environment like this in the same way if you hadn't had the kind of face-to-face opportunities to make those connections? Yeah,
of doing things, I suppose. I mean, we've established one way of doing something, which is, you know, where face-to-face is so important about establishing those relationships. Maybe that will also change.
Yeah. Yes, very likely. That's true. Kind of a social media way of working. I was just thinking more about the flow of information in terms of like Industry 4.0, because allegedly certainly in Australia, we don't really have any of that yet. We don't really, even though we've had this paradigm that's been with us now for multiple decades, we don't really have that seamless flow, even though we're now all sort of in the machine, in this ubiquitous kind of communication soup in Zoom and computation. We're not really making things through a kind of seamless process yet, I would say. So I'm sort of quizzical to see whether, in fact, this accelerates it, in the sense that now it becomes more critical to just be able to send the information and have a sort of more automated supply chain or manufacturing chain, or you know, and that construction, sort of the marriage of construction to something with a higher productivity, more efficient in a kind of manufacturing paradigm, whether that's accelerated by this. I don't really have a strong view on it. I mean, I've never seen such queues at Bunnings, which is our kind of home depot equivalent. Construction is one of the few industries that's just continued right through the crisis. And now the government is giving everybody 25,000 to do their renovations. So I don't think that is going to, we're going to keep construction alive, but I don't think that's going to feed innovation necessarily. In fact, it might be quite a conservative force, really. So I'm sitting on the fence in this, in terms of where we're going next and how it's impacted.
Interesting. Philip, your thought?
Well, no, I'm just nodding, because I do think currently it's about survival mode more than anything else, and so I think we need to either settle in this new normal or get past it to then really get back to the real key kind of issues, right? And so it's but for me also it's not just about necessarily all jumping onto an open source framework and all using the same. It's more even about making things more transparently available and sharing, and there's not that habit necessarily, and so sharing beyond. I agree with Roland. Sharing of concepts, ideas, thoughts, developments through engagement and discourse and visits and academic more and so on. That is extremely important, but really also sharing of solutions that are really scalable and meaningful and so on, and openness in also knowing what the options are. And that is something that I thought was quite interesting, that I organized a workshop between people that worked in refugee camps and so on, so providing solutions, and then the most digital people I could imagine, and to see if there was a common ground and a relevance between the high tech and the lowest tech. And at the end of the workshop, one of the main conclusion, which was a bit disappointing, was that we do see value in IT and so on in providing information. So that was their take home of the low tech colleagues. So that actually already offering for people that are in need. And I see this also a little bit in the questions somehow. It's the questions are like, what can digital fabrication and computational design really offer to me, for example, as a smaller scale office and so on. And so it seems that work needs to be done, and maybe this time of not being able to do physical stuff is maybe the time to take time to organize that, is really to clarify a bit more explicitly how these crazy spaceship kind of applications that the three of us have been showing how when you break them down, where components and aspects are directly relevant for not common, but for today more regular kind of practice. And so I think maybe, and that has been nice for my group in this COVID time, is because everyone was panicking, because we do a lot of experimental approaches, and in the sense that we build prototypes and so on. And then we were all like, what are we going to do now? We don't know what to do. And in fact, after a couple of weeks of kind of feeling uncomfortable, everyone started to reflect more and started to break down, why am I doing things, and how what I am doing could benefit other people and so on. But I think we need to do much, much more of that. And so I think this sharing of best practice somehow, and not in abstract and kind of high-end paper kind of versions, but really to break it down and to work harder on that transfer between academia and practice. Because otherwise, I mean, it's a little bit, I'm also distracted by the questions, but it's a bit kind of hard for me to read the questions, because I would love to talk with all of these people at length to actually clarify how what I have been showing is not just for the Zaha Hadid's in the world, but really makes sense also on a very small scale, even if it were to be to make one typical connection that you use 1,000 times to make it a fraction more efficient, for example, and to demonstrate how indeed computational design and digital fabrication can help with this, right?
Do you think this is where industry step in with academic and research, or into practice? Where do you think this will, who is best in position to kind of spearhead some of this? Do you think, Philippe?
I think it needs to come from us, and when I say us, from academia that is in a position that has sufficient funding and support to actually allow that risk to overcome. Because in practice there is just typically not the budgets or the opportunities to really dedicate funding and cost towards innovation, and this all goes together with, I think, to the 40-40-40 I was talking about. If there would be more public awareness, and by extension governmental pressure and action towards this knowledge that how much we are actually contributing to our planet and the challenges, the environmental crisis that our planet is into, then I think more funding would be made available and more budget would be. So, but currently it's not the case. And so it's us who need to act and who need to reach out and try to bridge that gap and try to indeed work together and translate some of our ideas. And but before we can even do that, we need to break it down and we need to clarify what could be relevant for our industry partners. And I think we do this way too little as academia.
Roland, your thought as a practitioner as well?
I guess there's yeah, I'm interested in Philip, your Compass project, and this attempt to try and share I guess all the kind of digital infrastructure and digital knowledge in terms of design process and the operation of robotics, etc. I think it's one really important form of information exchange. I mean, it's something that as my first practice, Kakuja was very involved in early on in our work, sort of 10, 15 years ago. We would share all our code and make it all available online. I think another one though is I tend to think that probably a lot of the new knowledge that we're creating in our group has got to do with detailing. It's got to do with like these things which are not, even though we're a group that's obsessed with generative processes and algorithms and robotic approaches. It's actually the kind of, in some ways, more old-fashioned architectural concerns which are perhaps the valuable in new IP. Like it's like, as soon as you start to try and make buildings which are 3D printed in plastics and reinforced with carbon fiber, the way you detail such a thing is radically different the way you detail another building. The level of resolution which you work on is radically different. to other construction techniques. And so there's a whole lot of know-how around detailing, which I think is really critical. And I think trying to work out how to disseminate that information is probably really important. So I'm not entirely sure how that, of course, there's the traditional methods of research papers, but there's probably other ways in which those methods can have an impact on industry outside of academia, which we need to explore.
I guess that's the role of researchers doing prototypes in a way that it is a showcase, a kind of an exemplar at a certain level. I think everyone on the panels essentially are doing this sort of work in the sense that we need to prove to the industry where that limits lies. And I think certainly in a lot of your work, Roland and Philippe's and Jane's work, there's kind of an edginess to it, right? And the edginess is about agitating the norm. And I think that I just want to talk about a little bit about the trajectories of future research. And I think there's a few questions on the Q&A, and I understand, Philippe, they are very distracting too because I'm going through them, and I'm also trying to focus on my questions too. But some of them we've really nicely in. There's a few questions actually about future trajectories of future research, and in terms of within your labs and where it will be currently or in the future. And so kind of the presentations, there's kind of essentially, if you like, kind of very bluntly two trajectories that one could call it, and the kind of the inventions of kind of, like I said, the radically new, as Roland was saying, kind of rethinking about the detailing from the kind of, because of the presence of a new technique or presence of new material systems, and the rethinking of kind of an existing practice, whether it's kind of using scan data from an already kind of timber manufacturing process, or using kind of vernacular geometries. So I guess I really want to kind of hear your thought about where you think future research should kind of focus in this space of digital fabrications and computational design. And on the second question is really what in terms of what do you think in terms of post-pandemic would demand from us as researchers to look more into more socially kind of relevant research area. Philippe, do you want to start off, or you're muted? Sorry.
Yeah, sure. Well, I'll start with the first one, with the future trajectories for research. I think it was clear from my introduction that I feel that it's important to go past Instagrammable, high visibility kind of prototyping. I needed it myself as a young researcher in order to establish ourselves, and that is extremely important. But to try to translate aspects there in things that make sense, and like you actually said, Paul, to focus on principles and strategies rather than very specific solutions. But I see a big, and I hope this is maybe a little bit different in Australia, but I doubt it, because it seems to be a worldwide kind of challenge for the field of architecture, is I see a challenge for researchers towards funding, because we typically get the following response, that if we don't, that our research is not fundamental enough, it's too applied. And then if you make it too applied, that you really argue for impact, and you go for, like, for example, you say this research is about optimizing a column. A column is in every single building, but we will make this better and relevant for an industrial, then it will be labeled as not interesting or fancy or fashionable enough, and then you also don't get the funding. And so I think we as a community need to also do better at clarifying why, and I really believe that why more funding needs to come to the build industry, and research that really develop, that really kind of addresses the embodied energy, the embodied pollution, and all of these aspects. And all three of us, we address that in different ways, but we can only address it in a limited scope, just because our research is not being recognized. It's not personal enough somehow. The problems that our industry are causing are too abstract. It's not like, it's clear for everyone that you should spend a lot of funding towards cancer research, because anyone in their family has been confronted with it. It's very clear that we want to fund research that kind of improves a site, because everyone wants to be able to experience world and so on. It doesn't seem to be clear enough, and we don't do enough effort to clarify why one should care about better design and better construction and so on and so on. And I see that as an extremely big challenge. And so whatever COVID does into this, what it does for me and my group is a time of even reflection, and hopefully be ready to attack that challenge even more strongly after. But I don't know, I keep saying the same, so I'm not sure if COVID is helping with this or not, but it's to me, this responsible design is the key target, and that I think research should target.
Jane, your thought?
Yeah, I think it's a really good point, Philippe. It sort of gets you every way, and in terms of the funding, you know, it's very difficult to get it right. And obviously, if you want to do any research which is even vaguely relevant and addresses any social issues, you need to work across a great range of disciplines and work with other people and really understand that context. And we can't be everything, you know, we can't know everything. And again, that presents challenges when you because it makes you harder to pigeonhole if you work with social sciences, or if you work with health, or this morning we were meeting about a project with neuroscience. So actually, and the neuroscience side I find very interesting, and the biometrics, because, and this is sort of bringing us back to COVID again, is that one of the things we're saying universally is that it's taken us back to these sort of core values. What do we care about? We care about family, we care about friends, we care about things which relate really closely to our emotions. So traditionally, in terms of building and designing and optimizing spaces, we've tended to almost try and make a very an environment in which you don't feel much, you know, that you stay at 22 degrees, that you stay at 34 relative humidity. Everything's kind of universal, and your experience of space is as ubiquitous as it can be around the world. But then it turns out that actually emotions are incredibly important, and when we're isolated, we suffer from mental illness and so on. But space has space and the way that we build things and the way that we make things has a lot of potential there. Whether it's through, you know, I talked about sound a little bit, but also, you know, it can be sort of the actual atmosphere, the color, you know, all these things. So I think we will get back in kind of future research, we might get back to some fundamentals connecting psychological kind of and emotional qualities. And in that process, inevitably going to have to mix with the scientists and think about metrics around that, probably to have any evidence of that, to think about how we actually make better places for people. And that's in Australia, you know, our average house size, I think, has shrunk to 240 square meters or something for a new house, you know. That's kind of crazy. Does it make you happier to have 240 square meters? A lot of European countries, the equivalent would be about 70 or 80 square meters. So we do a lot of redundant building as well. So could we, you know, I think through some of the kind of digital fabrication and this use of information, we've got the opportunity to quite affordably make things at an incredible level of resolution, of quality, of really, you know, built fabric and materiality that interacts with the in all sorts of ways with our kind of sensory systems. Maybe we don't need as much. Maybe we don't need to build as much, or maybe we could sort of turn our minds to some of the redundancy in all the building that we do as another approach, complementary again to looking at embodied energy in the way that we build.
Thank you, Jane. Roland?
Look, I'd like to second some of Philippe's comments. I think that translation to industry is an incredibly important thing. And, you know, I think the demonstrated projects that, you know, I do that, you know, Philip, you've definitely done in the past, they're important as a way of testing things and exploring things. But the really difficult step is how do you get those into industry and how do you make them robust enough? And I think that it's not just a translation to fabricators or not just a translation to the clients, but it's also a translation to bodies that regulate these things. It's actually having to have an impact on the standards. So if you're going to try and propose radically different building technologies and types, you actually need to do that within a framework of regulation that enables that. So I think that's kind of key thing that's not really talked about a lot, that has to be dealt with. I guess another thing is this sort of core concerns that Jane talks about and Philip articulated really clearly is the sort of the 5 E's. And, you know, of course, important one of those, the last two, sort of ethics and ecology, are incredibly important, but these are responsibilities that we have as citizens of the world. But we also have another responsibility, which is as architects. Now, architects are citizens of the world, and therefore they're responsible for ethical, ecological engagement. But so that's, I consider that has to be just a given in the way that so many issues of, say, for example, building science are given in architecture. I mean, architecture has to stand up, it has to keep the water out, all these things. It has to be ecologically sustainable. But that's not really what our expertise is. That's not really, I mean, of course we will do those things. Where our greatest value is actually to architecture. And so I think that within these discussions, you can never separate what the implications of these things are on architectural design, or how architectural design, through all of its other concerns, navigates the complexity of those kind of commitments it has as, you know, or we have as citizens of the world. So I think that I'm always a little bit worried when work is entirely couched in those terms, because I don't think that's actually, you know, that's our priority as citizens, which is not mutually exclusive to our priority as architects.
I think that's an interesting discussions. I'm sorry, Philippe, go. You go.
I just want to quickly say something to that. I obviously agree, but I think the reality is not at all as what you seem to suggest, Roland. I mean, making it kind of as an obvious kind of thing as a responsible citizen that ecology and ethics is important seems to not happen. That because otherwise, how can you justify all these kind of polluting, because highly inefficient and where only the bottom line of cost has been considered and not the real cost, because we don't pay the cost for society and health and so on and so on. Then it seems that people are not taking that responsibility towards ecology really serious, right? And why I specifically say ethics is actually really as a call of action, and particularly perhaps even to the structural engineers, that rather than being service providers that kind of make things happen and make it safe and say yes or no, the design team needs to include them as well, and people need to be challenged, and people need to know what the consequences of their kind of decisions are, and that's why I explicitly put them in there, just to have at least that like almost, yeah, it's a call, right, to remind yourself that you really should be, because there is a big difference between an architect and an engineer and any other citizen that needs to be responsible, is basically that the impact that we have with our decisions are orders of magnitude more important than what a regular person does just going about their regular lives, right? And so that is why I think we need to have an heightened sense and awareness and kind of reality check on what these kind of additional layers of responsibility are indeed that are expected from you as a designer, right?
No, look, I agree. I don't think we're, I wouldn't argue that, you know, we're all operating as good citizens. And so I think, you know, using that as a reminder is an important thing, of course. I think what our role is to now work out is what are the architectural implications of some of these things. And that's where it becomes really, really interesting, I think, because it's like whenever you have these kind of restrictions or you have these kind of like shifts in attitude or changes, it disrupts something. With that disruption, that potentially opens up a whole new space of design potential. And to me, that's where it's really exciting. Like, how does this radically alter architecture potentially, as opposed to, simply being about another kind of commitment.
No, but also, I mean, architecture in general, yes, but actually, and again, looking at the Q&A, I think we need to do better because all of us here on the panel, we know and we are convinced what the benefit and the offer could be of digital fabrication and more integrated processes through computation and so on and so on. But it seems very clear from all the feedback and just in general that we need to clarify more precisely what exactly we are offering with our research. And I know that I said this already, but it's for me a bit humbling to go through the questions and to notice this again, that we need to do much more effort because I do believe that we have some key solutions to many of the questions and challenges that we are talking about.
Jane, anything you want to add to this?
Sorry, I'm very distracted by the questions too. There's some great questions.
Yeah. Go on.
No, that's all right. You go ahead, Paul.
I mean, look, I think it's a very interesting discussion, especially the last few minutes. And I think one thing that we didn't really talk about, and there's a few kind of Q&A on question on the Q&A about aesthetics. And it's interesting that everyone here, all your work has a particular aesthetic tendency. Although apart from Roland, who explicitly talk about it, most of us almost treat it as kind of a consequences of the process, which is actually interesting because I think, and Philippe, one of your things apart from ethics is elegance in the work, and also I think, I think, to me, I think that's also another interesting discussion, which unfortunately we're going to run out of time because we're now at 7:29, which literally means that we're all going to have to go to another room, pour ourselves a glass of whiskey, and maybe we can chill out next time and have a more in-depth conversation. On that note, thank you very much to our panel. I'd like to thank Philippe Block, Jane Burry, Roland Snooks again for the conversations. And hopefully the conversations will provide our audience with a glimpse of the future trajectories of research, design, and construction in architecture. I'm sorry to all the audience because we do have 21 questions up there, which I hardly be able to go through it, and we didn't really answer all of them. I do apologize for that. We do have a limited time set. So this event is obviously recorded and will be available on the Melbourne School of Design YouTube channel very soon. And we hope you can join us again for the next MSD at home sessions. So thank you again, Philippe. Thank you again, Jane. And thank you again, Roland. Thanks very much for having this conversation.
Thanks, guys.
Thanks everyone.
Everyone.
Thanks.